Hey guys, welcome back to Genius Learning. In this video, I just want to show a quick example on projectile motion and how to calculate the time for a certain point in flight. Okay, so we have our projectile flying through the air in a parabolic shape, and we want to calculate right here what is the time. So we want to find this point here, and we want to find the time at this point. Okay, so we'll call that big T. And what we're gonna do is draw a straight line. So right now we see that the angle goes all the way to the initial velocity vector. So we're gonna cut right through it in the middle, okay? And we're gonna draw a straight line all the way to the point of interest. Okay, then we draw our line down, and I'm just gonna highlight this bottom part here. So we know that this is a 90-degree angle, okay? And we're gonna label this new angle beta. Okay, you could label it phi or whatever you want. I'm just gonna label it beta. Okay, so now we have this angle that is half or like a quarter or a small part of the actual theta that initially started. So this is the beta we have. And now, taking a look over here, this initial velocity could be broken up into components. Okay, so here we have opposite over hypotenuse. So V initial in the Y, which is up. Okay, we have V initial sine theta. And here's our x hat, so that's our velocity in the x direction. So adjacent over hypotenuse, this is V initial in the x is V initial cosine theta. Okay, so we have these two things, these two vectors broken up into the x and y. And remember, this vector is the same thing as this one. So we're going up here and we're going here horizontal. So our displacement vector equation can allow us to find our x and our y position, okay, just from the vector triangle. So I've explained the triangle. I just want to show that gravity or acceleration in the x is 0, right? We don't have it. And then acceleration, which is gravity, in the y. And this notation is the change in y, final minus initial, and initial we started at 0, so we're left with only the final. Okay, so now when we come over here, all we're gonna do is tangent of that angle beta. Okay, so tangent is equal to, in this case, we have y over x, or y final over x final. So we have tangent of beta is going to equal, on the top we have y, and we're going to change all these t's into the big T for final time. Okay, so we have the y that goes on top, v initial sine theta big T, minus 1/2 g big T squared. Okay, and that is over x, which is here. So we have velocity initial cosine theta big T. All right, so let's pull out a time from this term, and this term. And so we'll see that we're able to cancel one of them out, right? If we take out a t from here, a t from here, and a t from here, we'll have a t on top and one on the bottom. And so we'll cancel those out. We're only left with time here. So let's solve for that time, because that's what we want to know. At this point here, what is the time? All right, so if I put this on the other side, we're gonna have tangent of beta, v initial cosine theta, and then we're equal to v initial sine theta minus 1/2 gt. Okay, so let's put this on the other side. we got tangent of beta v initial cosine theta minus v initial sine theta is equal to negative 1/2 g big T squared. Okay, and then finally, let's take out these v naught from both of these terms. Okay, we're gonna multiply the 2 and then we're gonna divide by g. All right, so we'll do that and we'll multiply by the negative. So multiplying by the negative, let's just put a negative here. We're gonna change this to positive and we're gonna change this to positive. Okay, so I just multiplied both sides by negative. And now let's take out the v initial here from both of the terms. We got tangent of beta cosine theta left from this term, and that's a minus. All right, plus we got sine theta left there. Okay, and then on this side I'm gonna pass the 2 over, so it's gonna be 2v initial, and I'm gonna divide by g, so it's gonna be g divided by g, and then we're left with our t, which is the time that we want from this point right here. Okay, so just another quick way to solve for these things. I did another video doing the similar problem, but this one you can cut right through and just use a different angle, or you can use different identities for the sum or difference of angles, but just so you can see a different way to solve it.